Hello and welcome to this pre-recorded feedback event for the June 2015 Unit 1 Principles of Science exam. To help you get the most out of this feedback, you may want to have the following documents handy as we will refer to them during the session: unit specification, exam paper, mark scheme, and the lead examiner's report. Here are the aims and objectives of today's session. You will receive feedback on performance of learners in the June 2015 examination series. Consider questions where significant numbers of learners underperformed and possible reasons why. Discuss the lead examiner's report. Consider delivery strategies and share good practice. Address common issues. Find out about further support available. Please open the relevant unit specification. This external assessment is a 1-hour written exam worth 54 marks. The assessment includes a range of multiple choice, line matching, calculation, and written questions. There are 2 extended answer 6-mark questions, one of which is marks-based and one of which is levels-based. The unit covers learning aims A to F, covering biology, chemistry, and physics. In biology, learning aims A and B, candidates A. Explore cells, organs, and genes. B. Explore the roles of nervous and endocrine systems in homeostasis and communication. In chemistry, learning aims C and D, candidates C. Explore atomic structure and the periodic table. D. Explore substances and chemical reactions. In physics, learning aims E and F, candidates E. Explore the importance of energy stores, energy transfers, and energy transformations. F. Explore the properties and applications of waves in the electromagnetic spectrum. The first section of this paper was physics-based. Question 1 focused on types of energy. Learners performed well in the first 2 parts of Question 1A, being able to name electrical energy as the type of energy that powered the kettle, and then being able to name the useful energy produced by the boiling kettle. In Question 1A, Part 3, however, only some learners were able to name a type of energy wasted when the kettle is boiling as thermal, heat, or sound energy. A significant number of learners in Question 1A, Part 3 did not gain a mark here as they thought that steam was a form of energy that was wasted by the boiling kettle. Question 2 contained 2 calculation questions. Learners found the first of the 2 calculations easier than the second. In the first calculation, learners were required to calculate the power produced by Charlotte's Model hydroelectric power plant. The learners were given the time in minutes and the energy in joules. Although many learners were able to put the numbers into the equation to calculate the power, many learners did not study the equation carefully to see the units required, and therefore did not convert the minutes into seconds to obtain the correct answer and full marks. It is important that learners are always taught to check the units that are being used in the equation and the units that the information in the question uses, and, if they are not the same, to carry out the necessary conversion. In the first example shown on the left-hand side of the slide, the answer scored both marks, even without the working shown. However, learners should always show their working so that credit can be given for working that might be correct. This is especially important if learners make mistakes when working out their answers. On the right-hand side of the screen, we can see 2 examples of 1-mark answers where the learner has substituted the values of energy and time into the equation. Unfortunately, as they have not converted the minutes into seconds, they have only gained 1 mark. It can be seen that the learner in the second example has written the wrong answer on the answer line. However, as they have written their working, credit can be scored for showing how they have substituted the values into the equation given. It is therefore very important that learners are taught to all show all of their working so that when slips in the math happen, credit can still be awarded for the science that they know. Learners found the second calculation, calculating the useful energy, much more difficult, as they were required to rearrange the equation for efficiency that they were given, to be able to then calculate the useful energy supplied by the water. Learners did not always calculate the value in the expected way. However, full marks are always awarded for the correct answer on the answer line, as in the first example on the left-hand side. A common error seen in this question was where learners calculated the useful energy but then put it back into the equation again to gain a figure of 0.9. Learners that made this error but showed their working still gained 1 mark for calculating the 2430. Again, showing the importance of showing working, learners that wrote an answer of 0.9 with no working gained no credit. The last of the questions in the physics section required learners to describe differences between the properties and uses of radio waves and gamma rays. Learners in general found this hard, but some did well. In the first example on the left-hand side of the screen, the learner scored 3 marks. The learner states that radio waves are the longest. Due to the comparative word longest, this gained a mark for comparison of the wavelength. Later in the response, the learner has stated that gamma rays differ to radio waves because they are shorter but they are most dangerous, which also scored 1 mark for the comment on the relative danger. Finally, the learner has given a use for radio waves. If they had just stated 4 radios, this would not be credit-worthy. However, they have also stated mobile phones, which is acceptable. They give the comparison that gamma rays are used in cancer treatment. Together, these comparative uses gained a mark. Unfortunately, the learner did not make reference to the frequency of the waves for the final marking point. The better learners generally gave a concise and to-the-point answer that scored 4 marks, as in the example on the right-hand side of the slide. Here the learner has stated that radio waves have a lower frequency for the first mark and longer wavelength for the second mark. The converse is also given, that the gamma rays have higher frequencies and shorter wavelengths, in the answer, but by using the longer and shorter comparative words, this would not be necessary to gain the marks. They then go on to state that this means that the radio waves are no risk to humans. This is compared at the end of the paragraph to the gamma rays that cause cancer for the third mark. For the final mark, they give the use of radio waves to transfer satellite signals and uses of gamma rays, including for sterilizing hospital equipment. A very good answer for full marks. Section B of the paper concentrated on the chemistry in the specification. Learners found stating what Edward would have observed during the reaction of hydrochloric acid and sodium carbonate quite difficult. Better learners used the information in the question to help inform their answer. Learners that wrote bubbles or fizzing gained the mark. The fact that a gas is being created is not what would be seen in the reaction, but an inference from the observation, and so alone would gain no credit. It does not detract from the answer here, however, so the top example still gained the mark for bubbles. Unfortunately, many learners tried to answer a more difficult question that was not there. As in the second of the 2 examples shown here, the learner has tried to give the products of the reaction, not what would have been seen during the reaction. Therefore, no credit could be awarded. Even though the chemistry was correct, it does not answer the question that is being asked, and so can gain no credit. learners must be taught to read the question carefully so that they are answering the question that has been set, not a question they think is there. Parts 4A3 and 4A4 asked students to give the formula for two common compounds in the specification. Whilst it appeared that the majority of learners knew the formula, only the better learners were able to write it down using the correct scientific conventions. Many learners were unable to correctly give the formula for a molecule of carbon dioxide or hydrogen. The majority of learners lost marks, as they thought that the 2 should be superscript rather than subscript, as in the second example. Other learners seemed to be lazy in the way in which they wrote the formula, as shown in the third example for carbon dioxide. For the formula of hydrogen, some learners were confused and wrote the correct formula, but for water rather than for hydrogen. Some learners knew the formula, but as the hydrogen was represented by a lowercase h rather than a capital, could not score. It is important that when teaching formulae of elements, molecules and compounds, teachers stress the importance of the scientific conventions to be used when writing formula. Also, when reading the question, learners take note of what is required, in this case a molecule rather than an atom of hydrogen. Many learners lost marks on this question as they did not read the question carefully and gave the formula for an atom rather than a molecule of hydrogen, as in the last example on the right-hand side of the slide. Question 6 was the first of the two extended answer 6-mark questions with a points-based mark scheme. Learners found this question hard. Many learners did not gain full credit as they did not explain their answers. Centres need to prepare their learners for the exam by practicing past papers and exemplifying questions that require explanations. These questions will require the learners to give a point or fact and then explain that idea. Looking at the mark scheme for this question, marks were awarded in pairs, with the second mark of each pair being dependent on the first. In this example, the learner scored 4 of the 6 available marks. The learner starts by stating that fluorine's configuration is 2.7, which scored 1 mark. Unfortunately, there is no explanation to go with this in terms of how this explained the position of fluorine. If the learner has stated that this meant that fluorine has an atomic number of 9, or that it was the 9th element in the periodic table, this would have scored the second mark of that pair. The learner then goes on to state that chlorine's configuration is 2, 8, 7, which is worthy of another mark. Again, there is no explanation to go with this point. Lastly, the learner states that they have both 7 in their outer shell, and then gives the explanation, this means that they are in group 7, for the second mark. The learner then gives some information regarding the reactivity of the elements. However, this is incorrect, and so gains no credit. As in previous longer answer questions, learners that scored well tended to write concise answers that were to the point to score full credit. Section C of the paper tested the biology part of the specification. Question 7A was generally well attempted by learners, with many being able to give a correct example of a voluntary response and ways in which the human body responds to changes in temperature. The majority of learners were able to give a correct response of the human body to being cold. The majority of learners either correctly stated that the body would shiver or that goosebumps would appear. Learners that did not score generally did so as they did not use the science they had learnt to answer the question, but tried to apply general ideas, often incorrectly, as in this example, stating that the human would get a cold. In question 7b, part 2, learners could generally give a correct way that the body would respond to being too hot, Many stated that the body would sweat or that vasodilation would occur. Again, in a similar manner to question 7b Part 1, learners that did not score in 7b Part 2 generally did so as they did not use the science they had learnt to answer the question, but tried to apply general ideas that used no science. Learners found question 7c difficult. Those that scored generally did so for giving a correct comparative statement, as in this example, that the nervous system responds quicker. Those that did not score tended to make vague, generally incorrect comments on either the endocrine or nervous system. Many gave answers such that the nervous system uses nerves and the endocrine does not, which was not worthy of credit. In question 8c, learners found it difficult to recall a way that the root hair cell is adapted to its function. Only the better learners were able to state that the root hair cell had a large surface area, as in the first example. In many cases, the learners had misread the question and stated how the root is adapted to its function, giving the fact that it had root hairs as their answer. Learners generally found question 8d quite difficult. Some learners were able to score 1 or 2 out of the 4 marks available for giving a function of either the xylem and phloem or both. However, only the very best learners were able to explain how the xylem and phloem were adapted. In the example on the left-hand side, the learner scored 2. They give the function of the xylem and phloem, but do not explain how they were adapted to this function to gain the second mark for each. The example on the right-hand side shows an excellent answer in which the learner has correctly given the functions of both the xylem and phloem, and has correctly discussed how they are both adapted for their functions. Other learners did not understand the difference between the xylem and phloem and got the functions mixed. Some did not know which was which, so stated that both the xylem and phloem carried both sugars and water. This, therefore, did not score any credit, as it was not clear as to which the learner believed was correct. Question 9 was the second of the 2 6-mark questions that is a levelled mark scheme. The question tests the learner's knowledge of Punnett squares and genetics. In previous sessions, learners have seemed to be quite proficient at completing Punnett squares. However, in this session, learners seem to find it quite difficult to analyse the Punnett square. Only the very best learners were able to fully assess the Punnett square to explain why Hannah has brown eyes and Sam has blue eyes. In the first example on the left-hand side of the slide, the learner shows an understanding that Hannah has inherited one allele from each parent. This learner explains that Hannah has brown eyes because she has one dominant allele from Mrs. Williams and a recessive blue allele from Mr. Williams, and that she will have brown eyes as this allele is dominant and so this colour will be seen. The learner then goes on to explain how Sam has 2 blue alleles passed down, one from Mrs. Williams, who was heterozygous, and Mr. Williams, who is homozygous. They state that as there is no dominant allele, Sam would have blue eyes. This is an excellent example of a distinction-level answer, which discuss dominant and recessive alleles and explain why Hannah has brown eyes and why Sam has blue eyes. Unfortunately, the most common response seen was similar to the example on the right-hand side of the screen. Here, the learner has assumed that Sam was a boy and so took after the dad, and Hannah took after her mum. This very common misunderstanding scored no credit. In summary, learners tended to perform well in the short answer questions. Most learners showed an understanding of homeostasis and cells. Most learners showed an understanding of energy transfers. Learners seem to have improved in their ability to carry out calculations. learners performed less well in the extended answer questions. Key terms and knowledge of definitions are still areas which can be improved on. Calculation questions that involve rearranging equations or converting units can still cause problems for learners. Reading the question carefully and ensuring that the answer given answers the question that has been set. Understanding what is meant by question prompts, such as explain. Performance would be improved by more exam practice. In general, learners that did not perform well in this paper did so because of lack of exam practice. Learners must be given practice in reading questions and being able to understand what the question is asking of them. If the question is an explain question, then the learner must ensure that at least 2 points are made which are linked. If the question asks specifically for scientific reasons, then they must learn to draw from their knowledge gained during their science lessons to answer the question. Key terms and definitions should be practiced. When completing calculation questions, clear, organised answers will help learners that do not evaluate the equation to obtain the correct answer. Learners must have more practice in answering the longer 6-mark questions so that their answers address the questions posed and include as much relevant and scientific detail as it required in each case. Look at the example above, from Question 3, Part D. Using the mark scheme and the previous discussion, decide what mark you think should be awarded and why. This is a point at which you can pause the video to carry out the activity if you wish. Learners that did not do so well in this question lost marks as they did not give a comparison of the properties or uses, or because their answer was too vague. This following example gained 0 marks. Whilst the learner has made several attempts to answer the question, the uses given for radio and gamma rays were too vague. Learners should be encouraged to be more scientifically specific with their responses to questions. Simply stating that radio waves are used in radio is not specific enough. Similarly, simply stating that gamma rays are used in medical equipment is just too vague. In the same manner, the learner has stated that the frequencies of radio waves and gamma rays are different, but they have not stated in which way they are different. Again, look at the example above. This is the first of the 2-mark questions which has a points-based mark scheme. Using the mark scheme and the previous discussion, decide what mark you think should be awarded and why. This is a point at which you can pause the video to carry out the activity if you wish. The learner starts by stating that they are both non-metals, so are both on the right of the table. This point is worthy of 2 marks. They go on to say that they both have 1 electron in their outer shell, which is incorrect. They say that this means that they are in group 7, which is incorrect, and so no credit can be scored for this part. Although they have stated that they are in group 7, as they have not linked this to having 7 electrons in the outer shell, this is not credit-worthy. In the last section, the learner states that they both react with the same things, which is an acceptable alternative for react in similar ways. But as this is not linked to both requiring 1 electron to get a full outer shell, this mark was not scored. This is an example of question 9, the second of the 6-mark responses. Using the mark scheme, decide what mark you think should be awarded and why. Remember that this is a levelled base mark scheme and not a points-based, so you are not counting correct points made, but trying to assess the level of science knowledge that the learner has. At this point, you may wish to pause the video to carry out the activity. In this merit level example, whilst the learner has used the term genes rather than alleles throughout, the learner has shown a good understanding that Mr. Williams has 2 recessive genes, so he is homozygous for the trait of blue eyes. They also show an understanding that Mrs. Williams has a recessive and a dominant gene, so the dominant gene is for the trait of brown eyes. The learner has not referred to Hannah or Sam by name, but they have understood that the children have a 50% chance of having blue or brown eyes. Overall, the learner has shown a good understanding of dominant and recessive alleles and that the children have a 50-50 chance of having blue or brown eyes. In summary, to improve learners' performance in this exam, there must be time set aside to practice using past papers and addressing the learner's exam technique. Learners should understand that the answers they give should be relevant to the examples given in the question, and that where appropriate, they should use the correct scientific vocabulary that they have been taught. Each of the questions on the paper have been commented on in the lead examiner's report. This is another resource for you to use to help you understand the requirements of each question and to see what sort of responses were given by learners and how they were awarded marks. Some of the information from it has been used in this presentation, and if you are able to spend some time reading it, I'm sure it will help you gain further understanding. The report can be given to learners so they can see for themselves what is required for the different types of questions and how they can be awarded marks. For further support and feedback relating to this external assessment, please visit our dedicated BTEC results web pages. Our Getting Ready to Teach events will also be useful in providing support and guidance with the delivery of this qualification as a whole, and these can be assessed by clicking to see our full training offer. If you have any further questions, these can be directed to the subject advisor, Stephen Nugas. Thank you for taking time to listen to this event, and we really hope you found it useful.